Today I'm going to talk about the atom. So what is an atom? An atom is a tiny particle that builds up everything, except light that's made of photons. But anyways, an atom, A-T-O-M, is, like I said, a tiny particle that builds up everything. And is made of two things. So let's draw an atom right here. So this is the nucleus of an atom. And this, right here, this line, represents the electron field. Alright, so in the nucleus, there are protons, which we label as P+, and there are neutrons, which we label as N0. And in the electron field, there are, well, electrons, E-. Alright, so let's see how do they compare. This right here, what I drew, is an atom of hydrogen. H is its symbol. And this right here is one proton, and this is an electron. An atom of helium, for example, let's draw that, has two electrons, two protons, and two neutrons. Okay, so protons are positively charged, electrons are negatively charged, and neutrons don't have a charge. So why do neutrons exist? Well, protons are, as I said, positively charged particles, and they repel each other, which, causes them to go away from each other. And neutrons are there to stop them from repelling and keep the nucleus in place. Alright, so a neutron has a similar mass as a proton's mass, but their masses are 1,800 and something, let's say 800 times more massive than the mass of a single electron. Also, the number of protons in the nucleus is always equal to the number of electrons in the electron field, which means that they cancel out, and an atom doesn't have a charge. Also, neutrons are negatively charged particles, so that doesn't affect anything. Alright, now what are isotopes? I-S-O-T-O-P-E. Well, isotopes are atoms of the same element that differ only in their atomic mass. Now, to understand this, let's have an element E have an atomic mass of, let's say, 30, and the atomic number of 30, and the atomic mass of 60. This is the atomic mass. We label it as Z, and the atomic number, and this is the atomic mass. We label it as A. So, the atomic number is equal to the number of protons in the nucleus, and the atomic mass is equal to the number of protons plus the number of neutrons in the nucleus. So if we have an isotope of hydrogen that we drew over here, that's called protium. It has one electron, one proton, and 0 neutrons, so it's H11. If we draw deuterium, this is an electron, this is a proton, and this is a neutron. Now, there we go. Alright, so it is called deuterium, and we label it as H. Here goes 1, and here goes 2. Alright, let's draw down here. Let's draw this is called tritium. As you can see, it has 1 proton, 1 electron, and 2 neutrons, H1 free, and it is radioactive. It decays for about 12 years, and the reason it's radioactive is because you see protons are there to hold the nucleus together and make protons not repel from each other. And so hydrogen doesn't need any of that because it's just a single proton, but a neutron wouldn't make anything worse, so I guess you can add it there for deuterium, but 2 neutrons are they're just too much. Okay, so we can only by having a look at the element, for example, aluminium 24. Well, if we look at this element, we can see that Z is equal to 12, which is always equal to the number of protons, and as you can see, the number of protons is always equal to the number of electrons, so this is also equal to the number of electrons. And aluminium 13, sorry, that was sorry for that thing. And now it's, yeah, okay, so it's 13 right here too. Alright, and the number of neutrons is equal to A minus Z, which is equal to 13. 26 minus 13 is 13. Alright, so I'd say that has been it for today's video. Hope you enjoyed it, and you probably did since you watched till the end. So if you did enjoy it, subscribe and comment down below if you did. And I'll see you in the next one. Bye bye.